initial rates method. So we want to repeat an experiment several times using different initial concentrations of reactants. We only change one of the concentrations, keeping the rest constant. So repeat an experiment several times using different initial concentration of reactants, only change one of the concentrations. Some cases in exam questions you change more than one concentration, with the idea that we keep the rest constant. Calculate initial rate for each experiment and then see how the initial concentrations affect the initial rates and figure out the order of each reactant, and therefore once you know the orders of each reactant you can work out the rate equation. Measuring initial reaction rate. So for reactions with a sudden color change when a product reaches a certain concentration, in this case iodine clock solution, the reaction we're monitoring is H2O2 aqueous plus 2I minus aqueous plus 2H plus aqueous to form 2H2O liquid plus I2 aqueous. A small amount of sodium thiosulfate and solution and starch are added to reaction mixture. Sodium thiosulfate reacts instantly with the iodine formed. And once all of the sodium thiosulfate has been used up, any more iodine formed stays in the solution, turning the starch indicator blue-black. Varying the concentration of iodine / hydrogen peroxide and keeping everything else constant will give us different times for color change, therefore work out reaction. I think it should say order, yeah. Definition of continuous monitoring. Following a reaction by recording the amount of product / reactant at regular time intervals. Following a reaction by recording the amount of product / reactant we have at regular time intervals. So gas volume. If the gas is given off, we can collect it in a gas syringe and record how much at regular time intervals. We want to find out the concentration of the reactant at each time point. Use the ideal gas equation, find out the moles, use the mole ratio to work out the concentration of reactant. Loss of mass. If the gas given off of the system loses mass, we want to measure this at regular intervals with a balance and then use moles to find the gas loss, therefore moles of reactants left. Color change. We can track the color change using the colorimeter. Yeah. The more concentrated the color of the solution, higher the absorbance. More concentrated color of solution, higher the absorbance. So you can see here propanol and iodine, colorless brown to just colorless. So since the color has become less concentrated, lower the absorption. Absorbance. We can measure the change in absorbance by plotting a calibration curve, which is a graph of known concentrations of colored solutions plotted against abundance. Take a small sample from reaction solution at regular time intervals and read absorbance. Use a calibration curve to convert absorbance at each time point into concentration. And if there's a change in pH, the reaction produces / uses H plus ions, the pH of the solution will change. Therefore, we can measure the pH of solution at regular time intervals and calculate the concentration of H plus ions.